This is the Pearson Edexcel Core Pure 1, Paper 1 from November 2021. Let's just go straight ahead into it. Got a matrix question here. Transformation P is an enlargement, scale factor K from the origin, and then a rotation afterwards. Tell me what K and the rotation theta or the angle theta are. Well, okay, we can look in the formula book and see this. This is the rotation matrix here. Now the problem here is that we can't get cos theta or sin theta to be these numbers because these numbers are bigger than 1. So let's factorize out 4 from the entire matrix. And this looks okay because cos can become -1, but sine can't be √3. So I think what we actually need to do is take out an 8. And now all 4 of these values look like things we can get from sine theta and cos theta. That's good. You can actually just type these into a calculator until you find a value that works for all 4. So like 120 would work, cos 120 is this, and then minus sine of 120 is minus this, and so on. So I think I found this is good. I've got a scale factor of 8, followed by a rotation of 120 degrees anti-clockwise. And I think those are my 2 answers. So yeah, just use a calculator to your advantage if you don't know exact values, but make sure you get the matrix to have numbers less than 1 in it, essentially, in order to rotate properly. And yeah, sure. Square S, so let's just draw this. Got 0, 0, A minus A. 2A, 0 is there, I think. A is there, and A minus A is down here somewhere. Now, the first thing I want to do is work out the size of this square. So if this is 0, 0, and this is A, that means that the side length is this is A, so it's A squared plus A squared square rooted, which is just root 2A squared. And so therefore the area of this square is this times itself, which is just 2A squared. So that's the area of this current square. Now, the determinant of this matrix tells us the area scale factor. So let's go back to this matrix and find its determinant. It's going to be -4 times 1 minus 4 is 16, minus, but actually plus because of this minus, plus 16 times 3 is 48. So 16 plus 48 is 64. So the area scale factor is 64. So times that by that area, and we get this answer here. Of course, if we already knew that the linear scale factor was 8, that meant that the area scale factor was 64, which we could have just used as well. But always good to do things in a couple of different ways, maybe. Maclaurin series, look in the formula book. Here's Maclaurin series. This is the general one, and this is the one for cos. Now we're doing cos squared x over 3. So the first thing to do is replace that with an x over 3, and we get this. Now 3 squared is 9, which I can put on the bottom, and 3 to the 4 is 81, which I can also put on the bottom. So that's cool. But now we're doing cos of squared of this. So we're going to have to square this whole thing, by which I mean squaring this. Now we're only interested up to the x to the 4 term. So I'm going to think about if I expand this out, if I square this whole thing expanding out, which terms will actually give me x to the 4 or less. Now 1 times all 3 of the first terms will. So 1 times 1, 1 times this, and then 1 times that. So that's all these 3 terms. Now x squared times this first 1 in the other bracket will also work, so that's there. And then x squared times the other x squared will also give me an x to the 4. So that's there, so it's x to the 4 times this thing repeated and this thing repeated. And then x to the 4 times the first 1 will also give me, but then x to the 4 times x to the 2 is too big. And likewise on beforehand, x to the 2 times x to the 4 is too big, and 1 times x to the 6 is too big. So I think these are the only terms that are going to matter. If you just group them together via x squared and x to the 4s, you get this. Now I think I actually just said, yeah, it's minus 2 lots of those and plus 2 lots of those. And then this one was on its own still for a bit. Then I started grouping together, put them in a calculator, and you eventually get this. There is another way to do that, whereby you just convert cos into cos squared using the double angle formula, I think. But yeah, sure. I mean, there were other ways to do it, I guess. But yeah, I just did like that, and it got me the answer, which I think is right. Quite a lot of work for 2 marks, though. Bit weird. Anyway, part B, use that answer to estimate this. So we just shove this into here and do it between those 2 things. So, okay, well, you know, just notice there is a 1 over x in the front there. That's going to trip a lot of people up who aren't actually reading the question carefully. But there's 1 over x in the front, then you put your series expansion in. That, of course, makes this, and then this is just very easy to integrate. Just remember, x power minus 1 integrates to the log of x, and then we have this. We put the numbers in, really no special cause to do anything interesting or special there. We get the answer. 2 very easy marks at the end here. Use the function on your calculator to do this. Okay, boom. And then assuming the calculation part thing is actually correct, comment on the accuracy. Well, it's accurate to 1, 2, 3, 3 decimal places. And that's all the comment you have to make. So yeah, two very easy marks at the end there. Question number 3 then I think is what we're going to get onto here. So cubic this and then cubic this has roots that are related via this. So that means that w is equal to 4x minus 1, you can say, because the roots have changed by timesing them by 4 and taking away 1. And if we take that and we put it into here, so w is 4x minus 1, put that into each of these, and we get this. Expand everything out, do a bit of binomial expansion here, you get this, tidy it all up, you eventually get to this after doing a bunch of tidying, which means, of course, that a is, oh, in fact, no, not quite, because look, 19 needs to match with 304. Thankfully, 19 times 16 is 3044, so divide this entire thing by 16, and we get this. And that means that A is 4, B is 12, minus 12, sorry, minus 19 is minus 19, which is good, and then minus B equals all of this stuff. Okay, in other words, B equals all of this stuff. Notice how these two things are the same, and I've just found that B is minus 12, so minus 12 is equal to this, but minus 12 is 12, times by 16, take away 87, and we get C as 105. Cool, I thought that was quite an interesting question, actually. Nice little kind of change slightly of the usual type of question they ask about this. So that was cool. You could also, of course, do it by thinking about, alpha, beta, gamma, the roots and which thing equals which and the sums of the roots and stuff like that. But I think this is the easier way. Question number 4. So we have a matrix here, a 2 by 2 and a 2 by 3. Can you work out AB? Well, yeah, because this matches with this. So the columns of A match the number of rows of B. So we can do that. Can we add them? To add matrices, you need the dimensions exactly the same. So we don't have the same number of columns. So no. Okay, so the next bit, given this times this is lambda I, which is kind of interesting, find some stuff. So, okay, what we need to do is we actually just need to multiply this together, right? I think, so just looking at this, lambda I means that I can just write it like this. Looking at the first row and the first column, we can say minus 5 times 0 doesn't matter. But then 3 times 2 is 6, minus 1 equals lambda, so lambda is 5. And then I think I started looking at maybe the second row and the second column to get 5a plus 0 equals lambda, but lambda is 5, so a is 1. And then I think I finally looked at the last row and the last column to get that 0b minus a plus 3b is lambda, but minus a is just minus 1, lambda is 5, so that makes 6, 3b is 6, b is 2. And I think we have our answer. Deduce the inverse of this. Now, okay, so this times this is lambda I. So therefore, if I just scaled this matrix down by lambda, then I think I would have this times this is just I. So if I just take this matrix and divide it by lambda, that will be this matrix times this one is I, but that makes this one the inverse of this one, because that's the whole point of inverses, m times m inverse equals I. So this one divided by lambda is the inverse, I think. A lambda is 5, so it's just 1/5 of this matrix here. Can't be bothered to actually do that, but it's just going to be that. Given this, and okay, cool, determine the values for which is singular. Now, matrices are singular if the determinant of that matrix is 0. Oh, in fact, don't know why I have those coming up again, but I want the determinant to be 0 for a singular matrix. Now, the determinant of this matrix is 1 times this minus this times this, so that's this bit, minus 1 times this minus this times this, but that's just all 0 because of the 2 zeros here, and then plus 1 times 0, 0, 0, 0, so that's all fine. So cool. All of the remaining bits go away, and I just want 0 to be all of this. Of course, the 1 doesn't matter, so just 0 equals this for singular. Now, there's a couple of ways to do this. The way that I did it is just using the double angle rules. So sine 2 theta is 2 theta cos theta, 2 sine theta cos theta, and cos 2 theta is cos squared minus sine squared. Now I can write, I think I just wanted to write this all in terms of coses or sines. So what I did was I wrote sine squared here as 1 minus cos squared to get cos squared minus 1 minus cos squared, which is actually a plus cos squared. To get this, you can just go from here straight to here if you just know that double angle rule as well. This becomes sine squared, obviously. Replace that sine squared with 1 minus cos squared, I guess. Factorize out the cos squared. Factorize out the cos. You get this. Now this means either cos theta is 0, which is easy. That's just theta is pi over 2. I'm only allowed to be between 0 and pi, so that's the only solution there. Or this is 0. Move the 3 over, divide by 4, square root for root 3 over 2. Hopefully you recognize that. Remember to have a plus or minus. This means that cos is either pi over 6 or 5 pi over 6. There was a nicer way of doing that, which is to spot that you can actually deal with this a bit quicker if you use this formula from the formula book and let a equal 2b, then you have cos of 3b, if we're just reading the plus 1, cos of 3b equals cos of 2b, cos of b, minus sine of 2b, sine of b, which is exactly this, but the other way around. So you can just times this by -1. That doesn't matter, does it? Because this is 0 anyway. And you just get 0 equals cos of 3b. And you can solve that by just thinking about when cos is 0 and then just dividing by 3. You can increase the range by 3, of course. And yeah, I'm sure you know what you're doing there. It's quite a nice way of doing it. Good. So this question here should have probably animated in rather than just coming in straight away, which is annoying. But let's just read it as we go along. This is just very easy to integrate, right? We just integrate. It's easier to think about what would differentiate to this, I guess. Like when you differentiate this, you bring this, the derivative of -12x is just -12. So you bring that down. -4 times -12 is +2. So that just gets me there, and then everything else stays the same. So that's good. Substitute infinity, and you essentially just get 0 here. Substitute in 1, you get -1/2. So it just ends up being -4 e to the -1/2. So that's good. Part B is talking about the mean air temperature, which of course means we can just use the mean value theorem, which is just when we integrate across from the range, which is from, for the day, I guess, 0 to 24. So we're going to integrate from 0 to 24. These become 24 minus 0, and then we just integrate this function. And that finds us the mean value of this function in this range. So, okay, this isn't too hard to integrate. Just remember, these pi's do matter. You're not probably used to seeing them in the brackets like this. But when you would differentiate, say, cos of pi over 12t, you would differentiate cos to be minus sine, and then you would also derive pi over 12t, which is just pi over 12, and you would also put that in front. So just doing the opposite, I think I need this. So pi over 12 times 60 over pi essentially would make the pi's cancel. 60 over 12 is 5. So that's where I got this from. And everything else is just the same over here as well. Of course, just substitute in 24. When you substitute in 0, this goes away. This doesn't, which is why it's there. That just becomes a 1. And this goes away, so that's quite nice. When you substitute in 24, it's also quite nice because you get 2 pi here, and you also get 4 pi here. Cos of 2 pi is just 1. Sine of 4 pi is 0, so that goes away as well. And we end up with this cancelling with this, because those are both 1s there. And we just have 8 times 24 over 24, which is just 8. So yeah, quite cool. That just makes 8. Given the temperature was higher than 8, how could we refine this model? Well, we could get a mean value higher than 8 by just making this value a bit bigger, right? Because that would just raise the entire function a little bit, and that would therefore raise the mean by that same amount. So let's just increase 8 at the front by a little bit, and that would refine the model a bit. Cool. Question number 6. So we have a differential equations question here. When t is 0, x equals -20, the velocity, now velocity is dx by dt, so dx by dt is 0, and acceleration is d2x by dt squared. That's equal to 13.6. Determine the value of k. Well, we can just do that by putting in the initial conditions. So we can put this into there, this into there, this into there, and we can solve that for k, and we'll get k as 5. So this is the differential equation we're actually interested in. Cool. So we have this. Solve the auxiliary equation: 25w squared plus 10w plus 17. You can use whatever letter you want here. It doesn't matter. Solve that in a calculator. You get 2 complex solutions, obviously conjugates of each other. So we're looking for solutions of the form x equals e to the minus this, e to the this t there, and then a sine of this t plus b sine of that t. So that's cool. We have that. We can put in some initial conditions here, of course. We can put back in these two here. So x is -20 when t is 0. When t is 0, that just becomes a 1. That goes away. So we just end up with b equals -20, putting in this condition. So that's cool. We refine it down to this. If we differentiate this, we get 2 things. Differentiate this. This just comes down from -0.2. Leave all this alone, just doing product rule here. So this one differentiate first, leave that alone. And then leave this alone, differentiate this. Sine differentiates to cos, put the 0.8 at the front. Cos differentiates to minus sine, put the 0.8 at the front, get this. Of course, we now can put in 0 when t is 0. So this equals 0 when t is 0. When t is 0, this becomes a 1. This becomes a -0.2, doesn't it? This goes away. This is just a -20, which just times us by -0.2 to make it 2. This just becomes a 1, and we just get this becomes a 1, so 0.8 there. So I think we get 0.2 equals -0.2 equals 0.AA, which makes a, I think, ooh, have I done that right in my head? This is a 2, divide by 0.8, and I think we get 5, or -5. Does that make sense? Is 5 times 0.8 2? Does that make any sense to me? Sorry. this is a 4, isn't it? That makes a lot more sense now. 2 times 2 is 4, you muppet. So yeah, that's fine. That makes sense to me. We have this, and that's our particular solution, I think. So that's good. Hence, find, according to the model, the vertical height when t is 15. So we put t as 15 into this, and we get this answer. Now, that's not the answer, because you just need to read the question really carefully. I mean, this answer doesn't really make much sense, because now you're actually below the river. The question is talking about when the x is the height above a fixed point 30, above the river, when t is whatever time t is. So when t is 15, and you get this answer, that means that you are minus 0.7 meters above a fixed point 30, above the river. So okay, that means you're just below the fixed point by 0.7 meters, which means you're 29.3 meters above the river, right? So essentially, this is just saying you've come back up, you've bungee jumped, you've come back up to being just below this fixed point by this amount, which means you're this amount above the river, if that makes sense. Yeah, cool. Give a limitation of the model. I mean, just say whatever it says it is that you usually say. You're modeling the torus as a particle, I guess, for all of this. So that would be one reasonable thing to say. Anyway, question number 7, a vectors question here. So this is a plane in vector form. So what we want to do is show that this is perpendicular. To do that, we just want to show that this vector here is perpendicular to both direction vectors of the plane, which means just dotting it and making it 0, and just showing that it is 0. So dot this with this, and dot this with this, and show that both those things are 0, which they are. So this is perpendicular to both direction vectors, which means it's perpendicular to the plane itself. Now that means we can write this plane in the form r dot n, where this is n because it's normal to the plane, same as perpendicular, equals k, for some value k. So n is this, and of course to find k, we can just put in, this is not a direction vector, but this is just a random point in the plane. So put in this point into here to find what k is. 3 times 2 is 6, plus 9 minus 8, and we get k as 7, and so we have this as our dot normal product plane formula, whatever it's called, which means if r is just x, y, z, you can write this as 2x plus 3y minus 4z equals 7, and that will be our Cartesian form. The line L has equation this is a line now, where t is just something. The point A is on L. That means I can describe A as the point 4 plus t into as our x coordinate, minus 5 plus 6t as the y, and 2 minus 3t as the z. So that's my point A that I could use. And now, given the shortest distance is this, now there's a shortest distance formula in the formula book with a point alpha beta gamma, which is just this, and then the normal in Cartesian form is this. Just be careful, this 7 needs to go over there to be a minus 7 equals 0, but just that's fine. And then we have 2 root 29 is equal to all this. So we put all that in. So I've just put in all the information that I've just said into here. And we have this. This becomes a root 29, which is obviously good because we times it over here to make 29 times 2 is 58. I've just simplified all this down and do this. Now, how do I have possible coordinates here? Well, because this is a mod value here, right? So either everything inside here equals 58, which will be fine, or everything inside here equals minus 58, which modded would be 58. And so I have two things going on here. Either all this is 58, or all of it is minus 58. And of course, solve these things for t, and we'll have t is this, or t is that, and then put those t values into here, and we'll get 2 different points. Put t is 2.5 into here, we get a is this. Put t is minus 1.125, and we get a is this, and those will be our 2 coordinates. Question number 8 is another differential equations thing. We start with explaining where this comes from. So the container holds 10 and 20 liters. That's 30 liters initially. It gains 2 liters of red, loses 1 liter of blue. So it gains 3 liters per second, but then also loses 3 liters per second. So the volume is fixed at 30 all the time. The volume of paint is 30. We add red paint at a rate of 2 liters per second. So we gain 2 liters of red per second, but we lose 3 liters times the concentration of red. Now, the concentration of red, it tells us R is the amount of red. So the concentration of red is just R over 30 all the time because the total mixture is always 30. So red leaves at a rate of 3 times R, the total red, over 30, which is, of course, just R over 10. And then dr by dt, the rate of change of R, is just how much it goes in, 2 minus how much it goes out, R over 10. And we'll have this here, and so alpha is 10. by solving the differential equation, so we have to solve this. Now you can just separate this. This is actually a separable differential equation. It's more usual in these questions to use an integrating factor, so that's just what I did to make it more like it usually is. So the integrating factor, once you move the r over 10 over, of course, just move it over to make this. The integrating factor is going to be e to the integral of 1 over 10 dt. So we integrate this, that of course just makes 1/10 t, which is this, and that's, if I times all this by e to the, by this thing, this integrating factor here, what this means is this is now turned into a result of a differential by product rule. So it's going to be d by dt of something, and it's not too hard to see ever, I don't think. It's just going to be this. If you differentiate this first for dr by dt, leave this one alone, and then leave this one alone, differentiate this to make a 10th e to the 10 over t over 10, which makes this. And so we have our thing here. We can integrate both sides. The integral just cancels here to leave you with this. The integral of this is 20 e to the 10 over t over 10, I think, plus c, of course, because you've integrated. And that's going to be our general solution. Now we've got some initial conditions. We've got that when t is 0, r is 10. So we put those in. T is 0 makes both of these go away. And you get 10 equals 20 plus c, so c is minus 10. So we get this. And that's pretty much we're almost there now. We now need to know how long it will take for the mixture to contain equal amounts of red and blue. Now, I've said before that this thing always contains 30 liters. So to have equal amounts of red and blue, you can have 15 liters of red. So R should be 15. So we substitute in R is 15 into here, and we get this. We can, of course, solve this for T by just moving this, and then dividing by 5, and then taking log of both sides, times by 10. We get this, which is this, and to the nearest second, that is 7. Use this information to evaluate the model. So it says it apparently actually takes 9 seconds. Now, 2 seconds, if this was estimating the length of a year, 2 seconds wouldn't be a lot, but it's only a 9-second process, and we've estimated 7 seconds. That's over 20% of the actual time out. So that's probably not great. Say it's not great, and then give some kind of random justification for an answer like this, and you should be okay. Last question then. Use a hyperbolic substitution. So here are all your hyperbolic rules from the formula books. That's interesting. I noticed that we've got an x squared minus 1 under a root here. Now, this is probably the key one here, right? If you were to move this sine squared over, or in fact, if you were to move move the sine squared over, you get a 1 plus sine squared equals cos squared, which isn't of this form. So I'm not 100% sure what I'm talking about. Sorry, it's been a long day. I did this substitution mostly because you always do this substitution when you're doing hyperbolics. How does this even work out though? So you square it, of course, to get this. You take away 1 to get this. And then, am I just being an idiot here? You move this over, you get 1 plus sine squared is cos squared. Of course, you put the 1 on the other side, put the sine on this side, and you get cos squared minus 1 is sine squared, which is good, because that means I can replace all of this with the sine squared of t. Yeah, that makes a lot more sense to me now. Of course, you also have to replace x squared, which is just cos squared. You also need to replace dx. So dx by dt, cos just differentiates sine, which is fine. So dt, equals sine dt. So I can replace that with a sine, which is going to cancel with that one, which is good because, of course, this just becomes this, as I've said, because x squared minus 1 is cos squared minus 1, which is sine squared. So that becomes a sine squared. Rooted is just sine, cancels with that, and you're just going to integrate cos squared. Now, how do you do that? Well, you look at this here, right? And you say, okay, well, looking at this, sine squared, as I've already said, is cos squared minus 1. So this here, cos 2x, is cos squared plus cos squared minus 1, which is 2 cos squared minus 1, I think, which I can then rearrange to do cos 2x plus 1 all over 2. So I'll put the half outside, the all over 2, put that outside, and just say cos 2x plus 1. And then integrating this is not hard. I think I can just do that straight away. It integrates straight to sine, as it always does. Put a half underneath, put a plus t there, and of course a plus k because you're doing integration. So you have constant. Okay, and how do we get this to work? Well, what we want is equal this. Now this is looking pretty accurate, isn't it? Use this rule here. Sine 2x, or 2t, is going to be 2 sine cos. So replace that with a 2 sine cos. Of course, the half cancels with the 2. Cos t you already know is x. That's where that x is coming from. Sine t, you can just root both of those to get this, and you can shove that in as well, and we get this. T is, of course, just arc cosh of t. It's kind of interesting, actually. I was going to mention this earlier. Notice how in the question they use 1c here. PowerPoint is desperate to write 2c's. It doesn't let you type it in unless it puts 2 in. I just thought that was interesting, that there's apparently no agreed upon way of spelling this. But okay, cool. Anyway, we have this, and I think that will be the answer. So yeah, we have the whole thing done there, I think. Yeah, excellent. So the next bit, we're going to integrate this. Now, it says x greater than 1, so we're integrating between 1 and 3, it looks like, to get this done. So okay, we're going to integrate, we can also bring the 4/15ths out because it's just a constant, obviously. Now, how is this part relevant to this? Well, this is a product of integration, right? We're integrating two products here. Sorry, what am I talking about? We're integrating a product. Yeah, sure. So the one thing you could think of is, well, if you're integrating a product, integration by parts is quite helpful. And as soon as you do that, and as soon as you try it, you'll see why it goes quite well. So let's just choose to integrate this one. When I integrate by parts, I always just pick one to integrate or one to differentiate. Now, this works because when you differentiate this, you get this, which looks like something that is from the previous section. So, okay, good. So we integrate this for x squared over 2. And I've also just brought the 2, and then we integrate it again over here. And then we leave this one alone there, but then we integrate it here. And we differentiate it to get to here. And I looked up the derivative in the formula book was that. So, okay, just to go over that again, we integrate this for x squared over 2 for here. And then we put the bounds in, and then we minus the integral of, integrate that one again, and then just differentiate that one. Now, where's the over 2 gone? Well, I've just put it outside everything because I don't need it anymore. So therefore, it's turned into a 2 there. Good. Now, the integral of this is just this, right? So it's just going to be all of this between 3 and 0. Sorry, 3 and 1. The k doesn't matter, obviously. So good. Put that in there. I've put the 3 and the 1 into here. Arc cosh of 1 is just 0, so that goes away. So that's good. And then again here, you put in 3, you put in 1, but arc cosh of 1 is 0 again, so that goes away. So we end up eventually with this, I think, when you put in the 3 and the 1 everywhere, which is good. Does that all just go away? That's quite fun. That just all goes away. That's quite cool. I've also done 9 arc cosh of 3 minus a half arc cosh of 3 is 7 over 2 arc cosh of 3, and then this is just from here. Good, now root 8 is 2 root 2, which cancels with that 2 to just make minus 3 root 2. This 2 you can just expand out to make 1 over 15 into 17 minus 6. I did that, of course, because I was looking at the answer the whole time. And then, of course, we can just finally say that arc cosh from the formula book is written like this, log of x plus x squared minus 1 rooted. And I think that pretty much matches. This makes another root 8, which makes it 2 root 2, and we finally have exactly the answer they wanted. Excellent. I think that's the whole paper. Thank you for watching, and I'll see you next time.